All right, so in this video, I want to talk a little bit about the Voice VLAN and show a little example in Packet Tracer as well. But voice over IP phones were designed to replace PBX office phones that were on a totally separate network. So knowing that this would be an issue, that the idea was, well, because there probably in those days, there might not be a separate data jack to connect the phone to the data network. I had to think of a way to share that data jack, that port, with the PC, with the computer that was currently using that connection. So to accomplish this, most IP phones, including Cisco IP phones, have a little 3-port switch inside the phone. Now, it's not a typical Ethernet switch, as we'll see, but it acts as a Ethernet layer 2 switch. We'll take a look here. So 3 ports. One port, shown here in Packet Tracer here, was to connects to the Ethernet switch itself. There's a second port that's used to connect to the computer. That was typically already sitting on the desk. And then there's a third internal port that connects to the phone. Now, this 3-port switch does not send spanning tree bridge protocol data units like a typical Ethernet switch should. So as far as connecting this Ethernet port here, this port on the Ethernet switch to this phone that has a switch, we typically treat this port as if it was a regular host port, meaning that the device connected to it was just a single end device. So it's usually typical, we'll talk about this in later labs, later lectures, later videos, but we typically when we have a single end device, we configure spanning tree on this port to use something called port fast and BPDU guard. That's totally appropriate when we have an IP phone. So that'll work as well. All right. So IP phones have IP addresses. That's why they're called IP phones. So when we typically want to have this on a separate network than our typical end devices. So our end device will be on a separate network or separate VLAN. This network or VLAN that the end device is on is we'll see here in a moment, is associated with the VLAN on the Ethernet switch. We'll talk more about that in a moment. The IP phone will be on a special voice VLAN associated with its own network address. So the reason we do this is so that we can give voice over IP traffic priority in times of congestion, quality of service. So how do we separate traffic with different priorities? Well, as we've been talking with VLANs and trunking when carried over when carried over the same link, I'm saying single link, carried over the single or same link. Okay, so we'll talk more about this here. All right, so let's take a look at this port here. Okay, fast Ethernet /0/24. This is typically the default on most Cisco switches, switch port mode access. Okay, we are going to configure this port to be on VLAN 10, switch port access VLAN 10. Now you see I have here untagged native VLAN 10. That means when this port is receiving any Ethernet frames and there's no tag associated with it, well, just like a regular access port, it just associates that with, oh, what am I configured as? VLAN 10. Okay, that's coming in on a VLAN, that's coming in as a VLAN 10 frame. So I'll associate it with VLAN 10. Okay, that's for anything coming from this device here. I'll talk more about that in a moment. Now, as far as traffic coming in, frames coming in from the phone, that's going to actually get tagged with VLAN 90 by the phone. So when this reaches the switch port here, if it's untagged, associates it with VLAN 10, this device here, this network. If it comes in tagged, it's going to have a tag of 90 in our case, because I said voice VLAN 90. So if it comes in with a tag of 90, it says, oh, then this is on VLAN 10. This is the only tag allowed. So it's a kind of a special trunk link. There's always this little bit of a debate. Is this a trunk or no trunk? We won't go there. All right. So it allows voice and data traffic to be carried over a single network, two different logical networks, two different VLANs. Okay. So this tagging of VLAN 90 from the phone will ensure that we can prioritize when needed during times of congestion, prioritize the voice traffic using QoS mechanisms in our network. All right, let's take a look at this port here. This port here is designated just to be an access port, just to connect to a single device like our PC. Okay, it does not require any VLAN configuration. Okay, so what happens is this port, anything connected to this port, just goes all the way across here. Kind of think of it as a kind of a pass through, untagged. Okay, and will arrive here untagged B, which the switch port will treat this as access VLAN 10, VLAN 10 port, or VLAN 10 frame, excuse me. Okay, so that's why we have the switch port access VLAN 10 command. Untagged, no tag associated with, it's a VLAN 10 frame. Okay. All right. So once again, untagged traffic, I'm thinking that kind of, it's not really a native VLAN, but let's just think of it as untagged traffic, kind of like we see with trunk links as a native VLAN. But if I don't see a tag on it, it's VLAN 10. Came from this device connected to this port. All right, how about this port here? Okay, this port is configured automatically on the device here to understand VLAN tags. It's got to differentiate between voice and data traffic. So the switch port voice VLAN 90, we'll talk more about that in a moment. But what this does is it tells the phone, hey, associate traffic coming from the phone with VLAN 90, and it's going to get tagged as it goes across this link here to the switch. Okay, the IP's phone switch does not be, like I said, doesn't behave exactly like a traditional trunk link, but it does carry multiple VLANs, only two, right? It only carries the tagged VLAN, in our case, VLAN 90, that would be it. That's traffic from the phone itself getting tagged as VLAN 90. And any untagged traffic, which would be from this port here, from this device connected to this port, and then that'll be associated with VLAN 10. Okay, so again, the VLAN information on the IPv phone switch. The phone has a built-in switch. It doesn't need to be manually configured with any kind of VLAN information. Okay, it's actually capable of automatically detecting the correct VLANs based on the commands given right here on this switch port. Cisco IP phones typically are configured with a voice VLAN ID. In our case, we're using VLAN 90. This is, as I've mentioned, is used to tag the traffic from, let me kind of go here, there we go, from VLAN 90, which is associated with the internal port of the phone itself. That traffic will get tagged going across this link to the switch's VLAN 90. I want to mention too, is that the Ethernet switch communicates this voice VLAN. How does it get voice VLAN 90? Well, this is how it's done. The switch communicates this voice VLAN 90, in our case, to the phone using either CDP, Cisco Discovery Protocol, or LLDP, which is the IEEE standard similar to CDP, Link Layer Discovery Protocol. I won't get into that here. Okay. So once again, voice traffic, anything coming from the phone itself gets tagged as VLAN 90. Anything else coming from here does not get tagged, and its and the switch will assume that to be VLAN 10. Okay, just to kind of show you this one more time, VLAN 90, voice VLAN 90 tagged. Okay, now to let the phone know that we want it, that port is going to be that internal port, going to be, or internal VLAN is going to be VLAN 90. We can enable either CDP or LLDP, and I'm doing LLDP, two commands here. LLDP transmit, LLDP receive. That way the phone now knows, oh, the voice VLAN is VLAN 90. So it will tag frames from the phone to the switch with using VLAN 90. Okay, switch port access VLAN 10. That just says, oh, okay, this port is another for all other circumstances, it will be a VLAN 10 port, and that means anything coming from this device will have no tag and be associated with VLAN 10. Okay, so as far as the switch port goes on the Ethernet switch, the only traffic allowed is tagged VLAN 90 voice, where it can apply QoS, and untagged traffic. Everything else is associated with VLAN 10. And this is where we can also then start applying QoS classifications for quality of service. Okay, so I'm going to pause here for a moment and bring up Packet Tracer. All right, let's go ahead and configure this switch port here, Fast Ethernet 010. So let me do this interface, FA010. All right, let's do a switch port. Mode access. That's most layer 2 switches will default to that. Let's actually configure the voice VLAN, switch port voice. Well, yeah, switch port voice. There we go. VLAN 90. And just to make sure that our switch receives that, or switch on our IP phone receives this voice VLAN ID, we'll do LLDP transmit. And we'll do LLDP receive. Okay, now let's configure this port as an access port for VLAN 10, because that's the VLAN this device will be on here. So we'll say switch port, access VLAN 10. All right, that looks pretty good. And just like a regular, we'll be doing this for other labs, like I mentioned with spanning tree, but let me go ahead and add that right now. I'm going to just type spanning tree. Port fast. What this does is it allows this port to come up automatically in forwarding mode without having to go through the different listening and learning states. So it allows, make sure that any DHCP messages, discover messages, are being forwarded right away from this end device onto the DHCP server. Now, to make sure that we aren't causing any temporary loops or even permanent loops, I'm going to do spanning tree, one other command here. We'll talk about this more later. BPDU guard. This will error disable the port. BPDU guard. There we go. Error disable the port if somebody does plug in an Ethernet switch. Now, as I mentioned, the Ethernet switch on this phone does not send spanning tree BPDUs. So we don't want anybody connecting an Ethernet switch. If somebody does, if somebody connects an Ethernet switch here, it will send spanning tree, let's say Ethernet BPDUs, spanning tree protocol BPDUs, bridge protocol data units. And if somebody does, so the phone switch does not send those. But if somebody does plug in an Ethernet switch, and when it starts sending those spanning tree bridge protocol data units, BPDUs, this port here will now recognize that. And to guard against it, it will actually error disable the port. And then we'll have to go figure out who plugged in something of that before we enable the port back on. All right, let's take a look at a couple of things real quick. I'll do end here. So let's start with, how about show VLAN? So if you notice that FA10 is on the voice VLAN, and it's also on this VLAN here. Okay, so it's associated with both VLANs. Now, does that make it a trunk? No. Well, not depends who you ask, but not a typical trunk anyway. So let's show interfaces trunk. So Cisco iOS does not consider it a trunk. We do not see it in our list of our trunks. Our trunk link here right now is FA01 and FA02. FA02 is being blocked right now because of spanning tree until we configure Ether channel. All right, one last command, show interface FA010 switch port. And let's take a look at what this is showing us. Okay. Just want to show a couple of things here. Access mode, VLAN 10, but also voice VLAN 90. Yep. So anyway, that's where we can kind of verify that, and we're all ready to go with our voice over IP. Hope you found this video helpful. Have a great day.